Okay, welcome back Science 10s. In this lesson, we're going to be looking at Lewis dot diagrams. Okay, so we looked at Bohr diagrams before, and now we're just going to convert that into a Lewis diagram, and to be honest, I think it's quite a bit easier. Just going to remind you what Bohr diagrams look like. We showed the nucleus in the center, and we're going to do an example for oxygen. So you look up the atomic number on the periodic table, and for oxygen, it's 8, and that is your number of protons. Protons is equal to 8. Then you look at the mass. The mass is 16. You minus the number of protons to figure out how many neutrons there are. So a mass of 16 minus 8 protons, our neutrons are 8 as well. And they're often similar for those upper chemicals. Now we have to put the electrons on. There are 8 because it's the same number of protons. In the first shell, I'll switch to red here so it's a bit easier to see. There is 2, so 1 and 2 because 2 fit in. I need to put 6 more. I have to fill them in the clockwise position for north, east, south, and west. Now I'm at 6 total. I've put 1 in each position. I need 2 more. So I'm going to go 1 there and 1 there to get a total of 8. 2 in the first shell, 6 in the outer shell. Now that takes a fair amount of work to draw all that. There's a lot of drawing going on. So we're going to do a Lewis diagram that is much simpler. Because in the center, the protons and the neutrons, we were able to figure that out from the fact that it's oxygen. We're just going to put in the center the symbol for oxygen. So the symbol for oxygen is just O. So I'm not drawing another nucleus, it's just O in the middle, the atomic symbol. And then all we're going to give information about is those valence electrons, are the ones on the very outside. So we assume everything in the middle is full, and what's going to give it most of its properties is the outside shell anyway, when it hits into other atoms. So all I'm going to do is put those 6, but now I'm not going to put even a circle. I'm just going to draw the dots. So they looked like this. I had 2 there, and 1 in each of those spots. And that's it. That's all you have to do for the Lewis diagram. Put the symbol and put the valence electrons around the outside. So now what I want you to do is I want you to pause the video and try and draw the Lewis diagrams for all of these top elements. All right? So try and draw those. I know it's a lot, but it's a lot quicker to draw the Lewis diagrams and then compare them to this key. Okay, so here's the key. I hope that went well. You can kind of check through your answers and pause to make sure you got the right answers there, but we noticed some really big trends. Hopefully what you noticed is that in the columns or in the groups, there's the same amount of valence electrons. There's 1 in this column, 2 in this column, 3, 4, 5, 6, 7, and these 2 here have 8. Helium has 2. I'm still going to write 8 here because most of them all in this row have 8, but this one does have 2. I'm going to talk about why that is. Well, we know that in the second level of the electron shells, it fits 8, but in the first shell, it only fits 2. And we notice in this group is that all of those have a completely filled valence shell. Helium has the only electrons in the first shell because it's got 2 electrons and they're in the first shell is filled. When I go to neon, it has so many electrons that it goes in the second shell and it's completely filled with 8. Argon goes to the third shell and it's completely filled with 8 as well. And this brings up another point, that hydrogen and helium have their valence shell as the first shell. It's got 1 electron there and then 2. Once we have another electron to bump up into the next shell, we start here with lithium and we go down a row or down a period. So we learn there that now these periods here are showing which energy level we're talking about. These ones here is the first energy level, this is the second energy level, and the third, and it shows how much or how many electrons are in each of those. So that shows how the periodic table is organized, and it's organized really well. And another thing that you might have noticed was if you look on a data booklet, the numbers up here at the top, 1, 2, 3, 4, 5, 6, 7, 8, are already kind of given there. Now these 1 and 2 are actually 1 and 2. Over top of boron and aluminum is actually 13, 14, 15, 16. But if you just ignore that first 1, you don't even have to draw out a Bohr diagram. You can just tell how many valence electrons there are by looking at the number of that column. So without even looking, you could say anything in this column, because I see 13 at the top, means there's 3 valence electrons. Anything in this column is going to be 6 valence electrons. And that's a really fast way to look it up instead of having to do more diagrams. So these are the conclusions that are important. Groups share the same number of valence electrons. That's the columns. Periods, which is the rows, are showing what energy level those electrons are in, and it's in the same energy level. So first period, first energy level, second energy level. The metals and non-metals we'll talk about a little bit later. So that's all I really want you to look at for this lesson. We're going to talk about metals and ions in the next one, but if you could ask any questions in the live time, try the practice questions, and I'll see you in the next video.